Okay. Welcome back, ya Shabab. Today is the last lecture this week, since we have, inshallah, tomorrow the joyful celebrations starting for the National Day. Now, there are a few points that I would like to point to about some discussion in the previous lectures. The first one that I would like to point at was, mentioned to me by a student, and I thank him for that. I believe he is Mustafa. Yes, Mustafa. Mustafa Nuesra. I don't know if he's from this section or the other one, but what Mustafa did is the following. He went ahead for the problem, if you recall, the one with direct, with shear due to bending, which we have a beam with two forces of 40 kilonewton, and there was, I think, two support. There were two, okay? And if you recall, we calculate the cross-section is a hollow square. And what did we do? We calculated the shear stress due to shear force. And we found it here, tau max, and we found it at this point. Do you remember this, ya Shabab?
Yes, doctor.
Okay, good. Now, I made a mistake. I honestly I brought this problem to explain that if you go and find tau max, which is equals to 4, no, not 4, I think it was 3/2, 3/2 V over A, you should find the same answer. That's what I said, but the problem was brought to tell you that you will not find the same answer. The reason why is the following. If you go back to the lecture, you will find that there is a table. This table has 4 geometries. 4. One of them is a solid circle, cylindrical shape. The other one is a hollow cylindrical shape. One rectangle, I don't remember, was it a rectangle or square? But it is solid. And the other one, I believe it was like this, maybe. Or it might be, an I section. Now, the equation for tau maximum for these geometries were given, of course, at, each one alone. And for rectangle, it was given as 3V/2A. Now, I just want you to understand something over here. This equation is not the same as this one. And if you give me 1 second, I am going to give it to you exactly. For this one, tau maximum is equal to 4V/3A. This one, tau maximum, equals to 2V/A. Now, just to tell you something, the idea here is that when you have a hollow section, it is not the same as when you have a solid one. Do you understand that? And that's why when I said that if you go and use this equation by finding the area as, if you remember, this was 100 by 100, and this one was 76 by 76. I told you in the lecture that if you go and use the area 100 square or 100 by 100, and then 76 by 76, and plug it there, you will get the answer. This is wrong. You will not get the answer. You will get something different. And this is what Mustafa realized and told me. And then I said, oh, I shouldn't have said that. It was a mistake from me. So what I'm trying to tell you is that please correct this in your mind, and always remember that if this is true, we wouldn't need two equations for a hollow and a solid cross-section. It is different. Do you understand that? Okay.
Doctor, so you mean we
so what I am going to do, go ahead, ya Abdullah.
We should have an equation for the full square and then subtract the equation of the
square. I haven't seen an equation for a hollow rectangle. I was trying to find it in other mechanics books. I didn't search for a long time, but I didn't find one. Most of the books have an equation like this, the 4, similar to the table. It's in the slide, page number 42. Some of them have additional cross-section, but they are solid like a rectangle. So if there is no equation for this geometry, it means this is not the end of the world. You must calculate it yourself. Understood, ya akhwan? So what I'm gonna do, this recording will go with this lecture, and the lecture which I explain that this thing, I am going to either edit it. If I couldn't edit it, if I said that in the middle and it's gonna be confusing, I am gonna put a warning video in the beginning of the lecture so nobody understand this in the wrong way. That's comment number 1. Comment number 2, there was a student from the other section, he was upset. He said, no, not upset. He said, why, when you draw the Mohr circle, you don't use the, so I just was trying to get my hand over this. Yeah, now I think I am ready. So in your section, while I was, I was so much into the Mohr circle last time, I draw something not correctly, and I want you to understand it very well. So let me try to draw a neat Mohr circle. I don't know if I can do that now. No, I couldn't. So maybe, okay, if I can, it would be good. So that's why I don't do it. I was just trying to make sure that I know how, and I don't waste the time of the lecture. No, I still need some training, ya shabab. Let me tell you this, okay, shabab. What did I do? We had a Mohr circle with a center like this, okay? And then I draw the circle. And when I was, saying that this is the point where the X face is located, I think I draw the line like this. So what I did, I connected this point with this point, which was wrong. I did it because I was doing it too fast. I was trying to wrap up the material because we were running out of time. The Y, what are we doing here? This is the X face, okay? And I told you that this one is the Y face. I wasn't, you know, wrong in the sense that the y face is there and it has to pass through the center. But while I was drawing, I was supposed to draw this through the center of the circle. مو يا شباب السنتر حق الكوردينيت. So I should just remove this one. Oh no, where is it? This one. So the circle must be constructed like this. This is the center. This is the center of the circle. All what you need to do is to connect the point on the y and the x face through the center of the circle all the way to the other side, and then you will get the y face over here. Do you understand that? So please do not think that the center should go like this. This is wrong. This one is correct. These are two comments. I will also put this comment on the video for the last lecture, just to make sure that you didn't get anything wrong, okay? Because those videos are recorded. Okay. Now, what are we going to do, ya shabab? In 1 minute, I'm just going to talk to you about a 3D state, the 3D stress state, which was here. This is the general 3D stress. And if you see, this is a quadratic equation, okay, with too many unknowns. And in order to solve this equation, we usually need to do matrix analysis. So this is beyond the coverage of this course. But what you should know is that if somebody worked out those equations, okay, he will end up, if you want to get the principal stresses, you will get 3 this time. You will get sigma 1, sigma 2, and sigma 3. In general, ya akhwan, whenever we have a principal stresses, we arrange them automatically such that sigma 1 is the maximum, sigma 2 is the second maximum, and sigma 3 is the third maximum. يعني, if we found the first stress as 100, the second stress as 300, the third stress as minus 100, we arrange them such that the second, which was 300, is actually sigma 1, and then sigma 2 and sigma 3. Now, if you plot the Mohr circle in this exactly in a 3D, what will happen? You will again have, I know this is a small, but I hope you see it very clearly. You will have sigma 1 over here, sigma 2 over here, and sigma 3 over there. Now look carefully. The whole purpose, why are we talking about the 3D Mohr circle, is 1. 1 ya shabab. 1. What is it? عندنا يعني هذه تصير مصيبة. It's a big problem. It happens to students. So what is it? Let me tell you this. يعني I don't think you will ever that a 0 stress will cause a problem to you, but it is true. It's true. You need to teach yourself that even a 0 stress can cause a problem. Let me tell you how. If you have a plane stress problem and you draw the Mohr circle, واكتشفت انه المور circle جات هنا. احنا الان ما نتكلم عن 3D. We're talking about 2D. This is sigma 1 this is sigma 2. وخلصنا. That's tau 1 وهذا tau 2. There is no problem. You are very happy. وجينا وسألناك في الإكزام وقلنا لك اعطينا تاو ماكسيموم. احنا عشان ما نلخبط الطلاب شو نقول لهم؟ نقول لهم اعطونا الابسولوت تاو ماكسيموم. يقومون الطلاب يختبص، يقول غريبة. كانوا في العادة يقولون لنا اعطينا تاو ماكسيموم، واحنا نعرف انه تاو ماكسيموم is here or there. وش سالفة الابسولوت ذا؟ وش معنى الكلمة هذه فجأة كذا طلعت؟ Well, I'm gonna teach you before I ask you this in the exam. No secret. The problem is that if you have a 2D state 2D ايش معناه انه سيجما 3 يساوي صفر، صح ولا لا؟ انا قلت شيء غلط؟ ما قلنا شيء غلط. احنا قلنا يا شباب بانه if we have a 2D problem, the third dimension has no value, which means it is zero. هذا المشكلة. If I put 0 over here, that's sigma 3. Now, what the 3D state tells us? It tells us إنه في عندنا 3 circles. Circle 1 goes from sigma 1 to sigma 2. Circle 2 goes between sigma 2 and sigma 3. And circle 3 goes between sigma 1 and sigma 3. And this is the problem. The biggest circle has a bigger radius, and thus it has a bigger tau. فش اللي صار؟ اللي صار هنا إن أنت في الحقيقة عندك sigma 3 equals to 0. Therefore, وأنت يعني غصبا عنك مجبور إنك تيجي وتقول oh, there is another small circle over there between sigma 2 and sigma 3. And the scary sigma 1 and sigma 3 circle. Why is it scary? لأنه يا شباب أنت بيجيك المدير حقك في أرامكو ولا وبيقول لك صمم لنا البايبلاين هذا. Make this pipeline, make this pressure vessel. تيجي أنت مبسوط وتكتشف إنه it's a plane stress وسيجما 1 is positive وسيجما 2 is positive وتقول والله هذه ductile material. Ductile material is sensitive to shear. So, what I'm going to do, I will design this problem based on the maximum shear. وأنت مسكين تعتقد إنه الماكسيموم شير هنا كم؟ والله 100 ميجا باسكال. وتجيك الدائرة اللي لونها أصفر وتعطيك كف على وجهك. Why? Because tau في الدائرة الصفراء يا شباب maybe 180. وانت مبسوط وتقول لهم يلا اضغطوا الزر شغلوا البايبلاين وينفجر. Do you see that يا اخوان? It's so scary, right? So دائما احنا نقول اذا قلنا لكم absolute انتبه. طبعا اذا شوف يا شباب انا ما احتاج اقول لك absolute. انت شوف سيجما 1 وسيجما 2. إذا سيجما 1 وسيجما 2 صار واحد منهم بوزيتيف واحد منهم نيجاتيف عدد إيش معناها؟ معناها إنه في السيجما 3 هنا جالس. So you will have smaller circles inside. يعني معناها لا تهتم. أنت لما تأخذ سيجما 1 وسيجما 2 you are actually in the biggest circle. لكن المشكلة لما تصير المور سيركل كلها على اليمين أو المور سيركل كلها على اليسار. And this is very important. That's why we think that tau 1 3 tau اللي ما بين سيجما 1 وسيجما 3 is always the maximum. لاحظوا يا شباب even if sigma 3 is maximum zero I mean tau 1 3 is going to be maximum. Why? Because it is actually going to give you the stress from here to there, even if sigma 3 is zero. I hope you understand this very, very well.
دكتور.
Now, على فكرة يا شباب, التاو هذه, yes.
عندي سؤال. الحين في ال 2D إذا قال لي absolute maximum, we will consider قول الرسمة اللي على اليمين, okay? إنه ستريس 3 بزيرو. Okay.
You are breaking يا فيصل.
طيب تسمعني الحين؟
Can you say that again?
Is my voice clear now?
Yes, your voice is clear.
الحين if we consider the 2D الرسمة اللي رسمتها على اليمين.
أتوقع الدكتور عنده مشكلة.
يمكن عنده مشكلة.
I don't think I have a problem. You can hear me, right?
أيوة.
I can't. Did anybody hear Faisal? And maybe he can tell me what he said.
We heard him, but he didn't complete his question.
بكمل أنا السؤال. الحين إذا افترضنا الرسمة اللي على اليمين اللي هي 2D، حلو، والستريس 3 بزيرو، راح نعوض بالقانون اللي هو سيجما 1 minus 0 over 2 عشان نطلع الابسولوت ماكسيموم.
Yes.
Okay, that's my question.
Well, شوفوا يا شباب, as far as you arrange sigmas as sigma 1 is absolute maximum, sigma 2 is the second maximum, not absolute, it's maximum, and then sigma 2 is the second maximum, and sigma 3 is the third maximum. If you arrange them in that way, then tau 1 3 من المفترض انه هذا يعطيك الماكسيموم شير ستريس، حتى لو كان سيجما 3 is 0. بيصير عندك التاو ماكسيموم هو سيجما 1 over 2، هو الراديوس. This is sigma 1 over 2 في الكيرف في الفيجر هذا، وإن كان سيجما 3 is 0 اللي هو الراديوس of the biggest circle. على فكرة هذا التاو نسميه out of plane. ليه؟ لأنه في الحقيقة هذا مثل الجوست، أنت تشتغل على 2D problem وكل حاجة قاعدة تصير في البلين، هذا جاي برا من out of plane، طالع لك من البلين outside in your face. I will try to comment on this later when we talk about the failure theories, okay? Now we have a very important subject to finish because it is part these are examples of 3D Morse circle يا شباب. You can read them, they are very simple. What I need to do now is in the remaining part of the lecture to talk to you about the pressure vessels. Pressure vessels يا شباب are very important to Saudi Arabia, and يعني believe it or not, until today those little tiny pipes, they are some pipes are really huge, you can drive a car through them, but in most cases we can just see pipes. They look very simple, there is nothing moving, no robotics, no arms, no nothing. However, they are very tricky. We have probably in Saudi Arabia millions of kilometers of pipes. If we connect all the pipes in Saudi industry, they will go hundreds of thousands of kilometers, and yet they are pretty much settled. However, the pressure vessels with pipes are among the subject which was studied very well. We have good equations, good prediction theories, and so on. But still pipes, because they are very important, they transport water, oil, gas, chemicals, dangerous materials from one place to another. They are very, very important. And why they are a problem until today? Because they corrode, they got hit by something, and then they become weaker, and so on. So even now, Saudi Aramco is trying to spend tons of money to do research in order to say, okay, maybe we can have pipe made from plastic, composite materials, but they are not as strong. So scientists trying to invent new materials. We use pipes most of the time to transport, fluids. They are gas or they are liquids. Now, in Saudi Arabia, we have a huge oil industry, and there is submarine department in Aramco, ya shabab, where they deal with all offshore and water-related oil and gas drilling. But what you need to understand is that We have a fancy, sophisticated infrastructure under the water, like pipes transporting those chemicals and fluid and oil under the sea. So you can have a pipe, which you see over here. This is a pipe, okay? I'm trying to highlight. It has a thickness, right? The pipe has a thickness. Now, and what you also can see is that the pipe, just like I told you, إذا كان البايب يا شباب مدفون تحت الأرض أو مغمور تحت الماء, there is a good chance that you might have a significant outside pressure, which we will call B0. قاعد يضغط على البايب. Okay? At the same time, I mean, whenever we pump something, we pressurize it. And when we pressurize it, we will have an inside pressure, which is BI. Now, two pressures, and what else? We can have a very thick cylinder. Very thick cylinder. Something for a nuclear vessel or dangerous material. And what they do, they make the pipe very, very thick. Really thick. And sometimes we have a very thin pipe. You know, you barely, ya shabab, see the thickness. It's made from metal. You can't squeeze it with your finger, but it is very thin. These two classes are known as the thick wall cylinders and the thin wall cylinders. Understood, ya shabab? Now, if we have a thick wall cylinder, we will call the outside radius as R0. And we will call the inside radius as Ri. And any radius in between, we will call it R. R means, I don't know, is it outside or inside? It's in between. Okay? Any questions so far? All right. Now, what kind of stresses are generated whenever we pressurize a pressure vessel? You know, a pressure vessel, a cylinder. Well, أنا شرحت لكم مرة يا شباب لما تكلمنا عن ال vice wrench. You remember the problem when we have a clamp like this, and you need to imagine that at one time this vice will stretch apart, and at another time you can imagine that this vice is going to bend. Is that right? Do you remember this argument? Now, the same thing goes with the pressure vessels. So let me tell you, what do I mean? If you have a pressure vessel, ya akhwan, like this, there are two things happening at the same time. But احنا human, we cannot sometimes comprehend two things happening at the same time. So what do? We turn off one and we switch another one. And then we reverse them. We turn the other one and we switch the first one. So the first one that you can imagine will happen is like a balloon. لأنه هذا intuitive. Yeah? شيء نحس فيه. دائما نشوفه. When you put a pressure inside, what happened to the balloon? The balloon gets bigger and bigger and bigger. When the balloon gets bigger, its radius increase. It gets bigger and bigger. The stress which is generated in the material because you are making the radius bigger is called sigma R. Very easy, صح? You make the radius bigger, you have radial stress. Now, on the other side, ya shabab, if you push a pressure inside, okay, more and more and more and more, at one moment the balloon will burst. راح ينفجر. And when the balloon bursts, you take it and you look at it. If you get lucky and the balloon is still intact, يعني صار في البالون كراك بس وخرج الهواء، طلع الهواء، لكن it's still not shattered into pieces. You will realize that there is a line which cracked the balloon. Now, this line that cracked the balloon is actually another stress, which is always, if you take a cross-section here, you will see that this stress is trying to crack the balloon like this. هو هذا شغله. هذا stress دائما كأنه يجي ويقول لك أنا بأمسك البالون من هنا, I will pull it from this side, I will pull it from this side until I tear it off. طيب, هذا stress, if you go anywhere, you will find it acting like this. مهما حطيت خط يمر في السنتر, هذا stress عمودي عليه. السترس اللي يكون عمودي على الراديوس دائما هو tangential. هو في الحقيقة always tangent. عشان كذا نسميه tangential stress. انتهينا. Now, the interesting part is that you don't need to derive these stresses. Look at these two equations. The first one, for a thick-walled cylinder, the first one is the sigma T. The second one is sigma R, and both of them are function of R. ليه R يا شباب؟ لأنه المعادلة هذه شو تقول لك؟ تقول لك إنه stress يحصل هنا. But we don't know where. Is it this? Is it this? Is it this? أنت اللي تختار. والR يا شباب can reach to RI, يعني معناها المعادلة valid on this point, and also you can reach R0, which means that this equation is valid on the top. So, if you look, this equation is function of BI, is function of B0, is function of R0, and it is function of RI. The only unknown here is R. R هو الديستنس اللي انت تبقى تعرف وين تبغى تحسب stress. Do you understand that? Now, there is a special case when P0 equals to 0. When P0 equals to 0, المعادلة هذه تصغر. Why are we dealing with this? Is it because we hate big equations? No. We are engineers. We always deal with equations. It's okay. We can program them. There is no problem. But actually, if you go to Sabik, ya shabab, there are many chemical factory or chemical plants full of pipes, and they are exposed to air. We always consider that the atmosphere is a zero pressure. Actually, the stress, which is 101 kilopascal, is nothing compared to what is going on inside the pipe. For that reason, B0 equals to 0, the outside the pressure equals to 0, is a very good assumption. Of course, I'm not talking about buried pipe or a pipe which is going in the Pacific Ocean, under the Pacific, where the pressure there is huge, okay, or a submarine. So the equation will become smaller like this. This is sigma T and this is sigma R. Again, you have BI, R0, RI, but you don't have B0 anymore because it is 0. And also, don't forget that here in the denominator, we have R squared. R is the distance to where you want to measure the stress. Do you understand? Now, sometimes pressure vessels, نمشي احنا في الطريق يا شباب ونشوف tank like this, a pressure vessel which is closed. When the pressure vessel is closed, because we don't want the liquid inside it to leak out, okay, and there is an inside pressure, this pressure will push on the walls, generating the same stresses that we talked about inside the pressure, but it will also push on the top, on the ceiling. And when it push on the ceiling, الآن إيش صار؟ إحنا في البداية تكلمنا عن inside pressure. This inside pressure will generate stresses in here. But if we have a pressure along the axial direction, or what we call it the longitudinal direction, along this direction, the pressure will come normal to the surface. This pressure, we call it the longitudinal stress, okay? And it is measured as BI RI square divided by R0 square RI square. Do you see that? This is the stress. فعشان كذا إذا احنا قلنا open pipe، يعني مثلا البايب اللي ينقل الأويل من الشرقية إلى الغربية، that's a very long pipe. You will, although there is a beginning and end to that pipe, but because it's too long, we will ignore this. It doesn't make, you know, an effect on the longitudinal direction. But if you have a pressurized vessel sitting on the ground, مثل السلندر يا شباب حق الغاز اللي يستخدموا في الطبخ. This is closed. And there will be tangential, there will be radial, and there will be longitudinal. However, be careful. The radial direction, if it is too thin, might go to zero. I will tell you now, just in a minute. Look, ya shabab, this is the distribution of the stress in a thick-walled cylinder when P0 equals to zero. لو تلاحظون tangential stress راح يكون maximum in the inside surface, and it will drop but will not go to zero in the outside surface over here. So if I give you a case and I tell you where is the maximum tangential stress, you will probably evaluate it where at Ri equals to at R equals to Ri. This is where it is maximum. Of course, I am talking about the case when B0 equals to zero. And sigma R become maximum in the inside, but when you go to the outside surface, it reaches to zero. That's its distribution. So it is maximum in the inside, minimum or zero at the outside. Now, what happened لو تكلمنا عن السلندر حقت الغاز اللي نستخدمها؟ I don't know if you are using it anymore because people now have electric ovens. But what happened from the beginning of the lecture, I talked about a very thin cylinder. شنو هو consequences؟ consequences يا شباب إنه if you have a thin cylinder إيش راح يصير؟ تدرون إيش راح يصير؟ السلندر هذا يكون هنا. وزي ما انتم شايفين, if the cylinder is only this, what is the value of sigma R? Anyone?
Won't be zero. It will have a value.
It will be zero. It will be zero. But if you make this thin, sigma T will not be zero. For that reason, when we have a thin-walled cylinder, okay, we will only have a tangential stress. This tangential stress, sigma T, the average value, زي ما انتم شايفين يا أخوان, there is a value which is big here and there is a value which is small there. Okay, so the average, which is somewhere in the middle between the big and small, is calculated as the inside pressure multiplied by DI. خلاص ما في DO, راح نسمي stress DI, and divided by twice the thickness. If you want to find the maximum value, because there will be a maximum and there will be an average value, then this is equals to the pressure multiplied by the di plus the thickness divided by 2t. السؤال يا أخوان sigma r خلاص is equals to 0. If it is thin walled pressure vessel, السؤال كيف نعرف إذا هي thin or thick? Well, it is given to you right here, and you should make a very clear note of this comment. Look at it. ما تنسوها. When the wall thickness of a cylindrical pressure vessel is about 1/10 or less, which means that T divided by Ri is less than or equal to 1/10 of its radius, then this is called what? A thin-walled cylinder. عشان كذا من نعطيكم مسألة أول شيء تسووه إنكم تجون تأخذون الثكنس وتقسموه على الراديوس وتشوفون الرقم هل هو أقل من 1/10 اللي هو 0.1 ولا أكبر. And then if it is less than that or equal, you consider this as a thin-walled cylinder. If it is bigger, then you consider this as a thick-walled cylinder. Okay. Now, if you have a thin, yes.
The radius of the internal or the radius of the. We divide by which radius? اسمعوني يا شباب.
Can anybody hear فارس ويعيد لي السؤال؟
ايوه.
Divide by which radius?
Ali, want to say something?
لا دكتور بس بعد السؤال كان.
I'm sorry, Faris. Let's have your question later, okay? I have 5 minutes. I need to explain this and then start solving a problem because I want you to be ready for the homework. If the thin-walled cylinder, you have a thin wall, but it is closed. يعني pressure vessel, which is closed, and at the same time, it is thin. What is the longitudinal stress? It is sigma L, which is P di divided by 40. If you notice, this equation, sigma L, is actually sigma T average over 2. Why? لأنه sigma T average, لاحظوا, هو P di over twice the thickness. This one is over 4, so it's half of that, okay?